Hey guys, this is a video for solving systems by substitution. And this is the second day we are in this. We are in Unit 5. Our essential question is, how is a substitution method used to solve a system of equations? So as you can tell, my voice is not normal. It is a little bit raspy. I am recovering from a cold, so my voice is just recovering from that. All right, so we're going to review just things that we did in day one. So in day one, we saw that we had two equations, we had a system, and we were asked to solve. Now, when we're asked to solve, we're basically asked to say, hey, when do these lines cross each other, or do they ever cross, right? So we're given these two equations, and we're asked to use substitution. Now, with substitution, you want to find one equation that already has a variable by itself. So when I look at these, I notice that the one on the left already has x by itself. X is all alone. And x equals 9 minus y. So I'm going to substitute that into the other equation for x. Why for x? Because it says x equals. When I substitute something in, I always use parentheses. So I'm going to take out x, and I'm going to put in 9 minus y, and then everything else will stay exactly the same. The only thing I did was I took out x and I substituted in 9 minus y. All right, our next step here, 4 times 9 is 36. 4 times negative y is negative 4y. And then we have minus 3y equals 15. Well, now we have like terms. Negative 4y and negative 3y make negative 7y. All right. And then next step is going to subtract 36 on both sides because we're trying to get y by itself. So you have negative 7y equals 15 minus 36. I think this is negative 14, but I want to be double sure, right? Oh, it's negative 21. Wow, that was way off. Okay, negative 21. All right, and then we're going to divide both sides by negative 7. So that means y equals positive 3, because negative 21 divided by negative 7 is positive 3. Now, when we are doing this, we're not just trying to find only the y value, right? We're trying to find the solution point. So we need x comma y. Well, all I have right now is y equals 3. I need to get the other half of this, right? So, oops, I'm trying to circle this a lot better. So that means I have to pick one of my equations. It doesn't matter which one. I'm going to go ahead and pick the first one over here. X equals 9 minus y. I'm going to pick that one. And I'm going to use it to substitute in my new information. Well, I know that y equals 3, so I'm going to substitute it in for y. So x equals 9 minus 3. Well, what's x minus 3? I mean, what's x minus 3? 9 minus 3. 6. Because you plug in that 3 and you get 6. So this is the other half of your solution. So what is our solution point? It's the point 6, 3. So what does that mean if I were to graph these two equations? It means that they would cross at the point 6, 3. Okay? All right, so that's basically a little tidbit of what we did on day one. And just to make sure, if you're not able to do this, you might have to review before you actually attempt day 2. Because day 2 is basically the same thing, there's just one extra step. Okay, so looking at number 1, all right, we have two equations here, but neither of them have a variable by themselves. So now we have to do some manipulation to get one of these equations to have a variable by itself. Now, I could choose to get this y by itself, but that y is negative. We always want to choose something that has a positive 1 at the very beginning so that we can just literally move something and it's done. Well, in this first equation, I notice that x and y are already by themselves. So then I can choose. I can either choose to get x by itself or I can choose to get y by itself. I'm going to get x by itself. So I want to get x all alone, so what would I have to do? I would have to subtract y on both sides. So I have x equals 2 minus y. Well, then now basically we're at the same step, right? We're just going to use substitution. Well, x equals 2 minus y. X is by itself, okay? X is by itself, so I'm going to substitute this in for the x over here. All right? So now when I substitute in, I use parentheses for parentheses 2 minus y. I'm not really sure why I used purple here, but it's okay. minus y equals 8. So we're just substituting in. So really, the only step that's different is that very first step. You got to get a variable by itself, and then everything else is the same. So now we're going to do distributing next. 4 times 2 is 8. 4 times negative y is negative 4y. And then we have minus y equals 8. And then you check for like terms. Oops, these need to be black because I didn't even change these. I have negative 4y and negative y, which make negative 5y, because negative 4 minus 1 is negative 5. Okay, my next step here is I'm going to subtract 8 on both sides. So I have negative 5y equals 0. All right, and I'll divide both sides by negative 5, and y equals 0. Now this isn't my answer, right? It's not my solution, but it's part of it. So now I choose one of my equations. Now it's important here that you choose one of your original equations to make the least amount of mistakes. So it doesn't matter which equation you pick. I'm going to go ahead and pick the one over here on the right. 4x minus y equals 8. All right. Well, I know that y equals 0, so I can substitute in right here. So I have 4x minus, when I plug in 0 for y, the y goes away, right? We're taking y out, we're substituting in 0. Well, 4x minus 0 is just 4x. And so I divide both sides by 4, and I get x equals 2. So that's the second half of my solution. So the solution to this system of equations is 2, 0. That means if I were to graph this, it would cross at the point 2, 0. Just double checking to make sure everything makes sense. Yep. Okay, moving on. Number 2, same process here. We're looking for an equation that kind of already has a variable by itself. So you want to get the variable that just has a positive 1 in the front. Well, here I notice that this y is already by itself. So that's the thing I want to get by itself first. So the first thing I'm going to do is if I want y by itself, I'm going to have to add 4x on both sides. Y equals negative 17 plus 4x. All right. Next step here is to use substitution. Y equals negative 17 plus 4x. I'm going to plug this into the other equation in for y because it says y equals. So everything else is going to stay the same, but I'm going to substitute in negative 17 plus 4x in for the y value. Whoops. Okay. Next step here is we're going to distribute. So 4x is going to stay the same. We have 3 times negative 17, which I believe is negative 51. Yep, negative 51. 3 times 4x is going to be 12x equals 13. Then you check for like terms. Well, 4x and 12x are like terms. That's going to make positive 16x minus 51 equals 13. We're going to get the 16x by itself, so we're going to add 51 to both sides. 16x equals 13 plus 51 is 64. Divide both sides by 16 to get x by itself. We get x equals 4. So x equals 4 is part of my solution, and I'm going to pick one of my equations. Again, it doesn't matter which one. Let's go ahead and pick the one on the right here. Negative 4x plus y equals negative 17. Well, I know that x equals 4, so let's plug this in for x. So then I have negative 4, and in the parentheses, positive 4 plus y equals negative 17. Okay, so again, same steps as earlier in day 1. The only step at the beginning is that I have to get the variable by itself, so that all of the stuff in the green. That's the only new part about today. Negative 4 times 4 is negative 16. Okay, I'm trying to get y by itself, so I'm going to add 16 to both sides. And I get y equals negative 17 plus 16 is negative 1. So my solution is 4, negative 1. Oh my goodness, what is with my crooked lines? And why did this become pink? How weird. All right, I'm going to double check my answer real quick. Now you can check it by plugging your x and y value back into one of your original equations. Yep, okay. Just double checking there. All right, number 3, same process. You're trying to get a variable by itself because there isn't one already by itself. So back in that review for day 1, we didn't have to do any of that. So if you don't have to do any of it, then don't. But if you have to, you always want to pick the easiest route. So for example, I wouldn't try to get x by itself here because there's more steps to get x by itself. I would want to get this y by itself because there's less steps to do that. All I have to do to get that y by itself is to subtract 4x on both sides. Y equals 5 minus 4x. Now we're going to substitute in 5 minus 4x and for the y value in the other equation. So 8x plus 2, and in parentheses, 5 minus 4x equals 7. Okay, well my 8x is going to stay the same, but I am going to distribute the 2. 2 times 5 is positive 10. 2 times negative 4x is negative 8x. Equals 7. All right. Well, now I got to combine my like terms. 8x minus 8x. Well, what happens here? Well, 8x minus 8x is 0. 8 minus 8 is 0. So I don't have any x's left. 0 x's. I have 10 equals 7. Does 10 equal 7? No. It means what? It means I have no solution. So what does that mean if I were to graph this? It means that if I tried to graph this, I would have 2 lines that were parallel to each other because they have the same slope, okay? Now, because they have the same slope, they're never going to intersect, so they're never going to cross, so they have no solution. Moving on to number 4. Again, so we want to try to get a variable by itself. So I notice that I have a y here and a y here that I could get by themselves. But notice how one is negative and one is positive. We want to get the positive one by itself because we don't have to divide by negative 1 in the end. There's less steps on that one. So we'll go ahead and get that y by itself by subtracting 5x on both sides. Y equals 9 minus 5x. Okay, we're going to substitute 9 minus 5x in for y because it says y equals 4x minus, and in parentheses, 9 minus 5x. So everything else stayed exactly the same except y went away, but that negative sign is still there. Well, you're like, well, now what? I don't know what to do because there's no number in the front. Well, this is still 4x. Well, what number is really in front of those parentheses? A negative 1. So what's negative 1 times 9? Negative 9. And negative 1 times negative 5x is positive 5x. Equals 18. Okay, we're going to combine like terms. 4x and 5x combine to make 9x. And then we're going to add 9 to both sides to get 9x by itself. Divide by 9. We get x equals 3. So this is part of our answer. Now I'm going to pick an equation. It doesn't matter which equation I pick. I'm going to go ahead and pick the one on the left. I could pick the one on the right. Oh my gosh, I'm getting left and right mixed up. I could pick the one on the left, but I'm going to go ahead and pick the one on the right just because. 5x plus y equals 9. So the next thing I'm going to do is I'm going to substitute in 3 for my x value because I know that's equal to 3. So we have 5, and in parentheses, 3 plus y equals 9. Well, 3 times 5 is 15. So when you get y by itself, so we have to subtract 15 on both sides. We get y equals negative 7. Negative 7. Negative 6. Go crazy, crazy. I typed it in my calculator wrong. 9 minus 15. Yeah, negative 6. So that is not my answer, but it is part of my solution. So my solution point is 3, negative 6. And I'm going to double check to make sure that works. 12 plus 6, yep. And then 15, yep. All right. Number 5. Okay, now looking at my 2 equations, which one of these would be easier to get a variable by itself? Well, notice this y is already kind of alone, so let's get that y by itself. It's not always going to be y, it just happened to be y in a lot of these problems. So we're going to subtract 4x on both sides. I also noticed 4x shows up a lot, so I'm sorry about that. Should have came up with better example problems. Okay, well, I'm going to plug in 24 minus 4x in for the y because it says y equals. I'm going to plug it in for y in the other equation over here. Give me 1 second. I'm trying to fix this. All right. So then I have negative 12x equals 3, and then I'm going to substitute in 24 minus 4x, and then minus 72. So everything's exactly the same, but I plugged in my y value. Okay, well, negative 12x stays the same, and then I have 3 times 24, which is 72, 3 times negative 4x, which is negative 12x, and 3 times negative 72, or not, whoa, I broke a rule there, I'm sorry. I was just zoning off, I guess. I didn't even pay attention what I did there. Okay, so now we're going to combine like terms. Well, we have 72 minus 72. These are like terms. I can combine these, right? What's 72 minus 72? 0. So I have negative 12x equals negative 12x, right? Because 0 equals 0. Well, I got to get x on one side because I'm trying to get x by itself, right? So we're going to have to add 12x on both sides. Well, negative 12 plus 12 over here is going to cancel and gives me what number? 0. Negative 12 plus 12x on this other side still gives me 0. Does 0 equal 0? Yes. So what does that mean? It means I have infinitely many solutions. So we have infinitely many solutions when we have two numbers equal each other. Earlier we saw no solution. Now no solution happens when you have two numbers that don't equal each other. So back there we had 10 equals 7. Well, that's not true. Remember, if it makes no sense, it's no solution. Okay? But if the numbers make sense, then it's infinitely many. So if I have 2 equals 2, it's infinitely many solutions. If it's 5 equals 5, it's infinitely many solutions. If it's 7 equals 10, no solution. All right, so we have two problems left in the notes, and they're both word problems. Now, these are word problems that you've kind of seen before, just the way that they're set up. But these we will be solving by substitution instead of graphing. So number 6, Kate is 16 meters from Kate is 16 meters from a forest, running away at 4 meters a second. An angry coyote comes out of the forest running at 8 meters per second. Write and solve a system of equations to find how long it will take the coyote to catch up to Kate. So basically there's two things going on here, right? Kate's running out of the forest and she's going a certain speed, and the coyote's running out of the forest at a certain speed. Okay, so sometimes in these problems, if it's not clear at the very beginning, let's come up with the equations first. So let's start off. Well, we know Kate is 16 meters away from the forest and she's running at 4 meters a second. So in equation 1, we know she starts 16 meters away and she's running 4 meters a second, so plus 4x. Well, this needs to be an equation, so I have y equals 16 plus 4x. So this represents Kate. Kate is already 16 meters away and then she's running 4 meters a second. The angry coyote is running 8 meters a second. Okay, well, it looks like our second thing is the coyote. So it's going to be y equals, well, it's running 8 meters per second, so 8x. How come there's no number being added or subtracted here? Because a coyote doesn't have a head start. Kate had a head start of 16 meters, so we have 16. But because a coyote starts in the forest, then it's just plus 0. So if you want to, you can put plus 0, but we don't have to. So now let's come up with our variables. Well, let's think about this. Kate starts off 16 and she's running 4 meters per second. So the coyote is running 8 meters per second. So our x variable is going to be the number of seconds. Well, what happens as your seconds go on? After each second, what's happening? Their distance is increasing. So that means that if their distance is increasing, the y is going to be the number of meters they've already ran, right? How far they are. Okay, so now that I have my two equations and my two variables done, now I can solve using substitution. I'm going to go ahead and copy these problems down, probably at the bottom down here. because we got a lot of room. Y equals 16 plus 4x, and then y equals 8x. All right, well, now I got to use substitution, but you're like, well, both of these already have a variable by themselves. So then it doesn't matter. We can plug this one into that one, or we can plug this one into this one. It doesn't matter what we want to do. So let's just pick one. Let's pick this one. Y is already by itself, so let's plug in 8x. Okay, it says y equals. So where am I going to plug in 8x? For the other y. Okay, so then I have 8x equals 16 plus 4x. Okay, I'm plugging it into my y. It says y equals. So now I want to combine like terms, but they're not on the same side. So I got to get the 4x over to the 8x. Well, how will I do that? I'm going to subtract 4x on both sides. So I get 4x equals 16. So I got to divide both sides by 4 to get x by itself, and I get x equals 4. Well, that's part of my answer, right? It's not my entire answer, but it's part of my answer. Well, what do I know? Well, I got to plug it back in to find the other half, right? So let's pick an equation. It doesn't matter which one. Let's go ahead and pick this one. Y equals 8x. We're going to plug in x equals 4 in for the x value. So you have y equals 8, and in parentheses, 4. Wait, why did this turn red? I'm so confused. All right. There we go. Well, what's 8 times 4? 32. So that's the other part of my solution. Now I could write a point here, but remember, this is a real world problem, so let's answer the question. Instead of writing 4, 32, what does our solution mean? Well, what does the x value represent in my problem? The x value represents the seconds, and the y value represents the meters. So that means that at 4 seconds, they're both at 32 meters. Or in other words, after 4 seconds, the coyote has caught up to Kate. So after 4 seconds, they're both at 32 meters. Okay, moving on. Number 7, Bill purchased some neon fish for $2 each and angel fish for $3 each. He bought a total of 20 fish for $45. Write and solve a system of equations to find how many of each type of fish Bill purchased. So we've seen this problem before. It's actually in our setting up systems notes. Well, let's start off with our first variable. Well, we know that we're talking about 2 types of fish here, and we're asked to find how many of each type of fish we've purchased. Usually when they've asked us that, that's really telling us what we want to find for our variable. So our first variable is going to be x, and I'm going to call that the number of neon fish. And y is going to be the number of angel fish. Well, it says that neon fish are $2 each and angel fish are $3 each. So our first equation could be 2x plus 3x. And remember, the thing I taught you is that all your money usually goes in the same equation. So $2 for each a neon fish, $3 for each angel fish is going to cost me $45 in total. Now once I've used those numbers, I can't use them anymore. Then the second part says he bought a total of 20 fish. So the number of neon fish plus the number of angel fish should equal 20. X plus y equals 20. All right, so I have 2 equations. Now we're going to use substitution. Ooh, whoops, I made a mistake. So I should have 2x plus 3y because it's $3 for each angel fish. So sorry about that. Just caught it. So 2x plus 3y equals 45, and x plus y equals 20. Well, I need to get one of these variables by themselves because it doesn't already have a variable by themselves. So I'm going to pick either x or y to get by themselves. So I'm going to get x by itself. So I'm going to subtract y on both sides, and I get x equals 20 minus y. Okay, you can get y by itself if you want to, but I wanted to get the x by itself. So 20 minus y, I'm going to plug that in for the other equation. I'm going to plug it in for x because it says x equals. So I have 2 parentheses 20 minus y plus 3y equals 45. Okay, I'm going to distribute 2 times 20 is 40. 2 times negative 2 is negative 2y. Plus 3y equals 45. Okay, well, I have like terms here. I have negative 2y and positive 3y. That's going to give me positive 1y, or just y. So everything is the same, but I've combined my like terms. And I'm going to subtract 40 on both sides. So y equals 5, because 45 minus 40 is 5. So that means y equals 5. Well, what does that mean for my problem? Well, what does y represent? The number of angelfish. That means he's purchased 5 angelfish. All right, so now I got to pick one of my equations so I can figure out how many neonfish we bought. So I'm going to go ahead and pick this second one over here, x plus y equals 20. Now I'm going to plug in this y value in over here. So I have x plus, in parentheses, 5 equals 20. Well, I got to get the x by itself, so I have to subtract 5 on both sides, and I get x equals 15. So my solution is the point 15 comma 5, but what does it mean? Well, what's x represent? The number of neonfish. So that means he bought 15 neonfish, and then what's our y value? 5, and that means he bought 5 angelfish. All right, so that is it for our notes over substitution. If you have any questions, just please feel free to come in for tutoring. I am here to help. But other than that, that's it. Nothing different from day one, just that we have to get one of the equations to get a variable by itself instead of it already having one by itself.